start at the beginning. All right, so hey guys, I'm Nathan Fuller. I'm the CEO and co-founder of Fuse Machines. And so today we've been hearing a lot about how manufacturing is becoming more accessible as well as easier to use, right? That's what everybody's talk today has been talking about. And so Fuse Machines noticed that a lot of the users who are doing this are either engineers, product designers, or makers. But when they look at what they want to do and how they want to make their designs that they have, they run into some shortcomings. So traditional 3D printing is really cool, it's really flexible, it's really easy to use. But if you look at the parts, a lot of them come out kind of rough. It's more of an approximation. And so the accuracies and the surface finishes just aren't there quite yet, specifically with the FDM 3D printing. So on the other hand, CNC machining is really capable. We're able to go in and machine things to incredibly precise finishes and accuracies. But running a CNC tool is its own career. There are professional CNC machinists, and the CNC machines often cost large sums of money. So Fuse Machines thought that maybe we could marry these two, and we created a technology that we call dual sculpting technology. So dual sculpting technology is the intelligent integration of additive and subtractive in one tool and one piece of software. So what that means is that at any time during the printing process, we're actually able to come back and machine away those inaccuracies. So all those little parts and areas that you don't want to print start to go away. And so our customers are really interested in the technology, but what they really want is a solution. So I want to introduce you guys to the Orsys, which you guys can see sitting right here. The Orsys is the world's first desktop dual sculpting manufacturing platform. This means you can get machine-grade results on your desktop with all the ease of use that you're used to getting on a traditional 3D printer. So I have to admit, I told a bit of a white lie in the beginning of this presentation. This part wasn't machined by a CNC machine. This was actually machined on my desktop, on my Orsys. And so we're actually able to get these results that are really different than what people are used to getting on a 3D printer, and we're really excited about what that can mean. So what exactly is the Orsys? Well, it started off with a really world-class 3D printer. So we built this printer from the bed up, which means that we had to start rethinking everything. So we had a precision ground piece of aluminum, which is cast to prevent warping. We have 600 watts of heated bed power, as well as a build tack layer, which is basically a third-party surface that really makes printing way more reliable. And all this is in an effort to make failed 3D prints, because anyone who's 3D printed something has had them fail. That's just not what we want. We want to make that a thing of the past. So that's really what we've tried to do here. Now, all of this combined with our all-metal hot end, we actually print in a full enclosure, just like a plastic fab does. And what that does is it creates a microclimate, which allows the materials in it to not warp as much, not experience as much stress. And so we're able to print not just in the PLAs and the ABSs, but also in things like nylon, polycarbonate, which is the same stuff bulletproof glass is made out of, right? So we're really working on pushing the limits of what people think they can do with this technology. But it's not just a 3D printer. The Orsys also has a 150 watt CNC spindle in it. So we can machine wood, plastics, and my favorite, we can etch PCBs. So imagine you're making a project, you can actually design the circuit board as well as the 3D printed parts and make them all on one machine on your desk. But perhaps the true power of the Orsys is using this dual sculpting technology. So on the your left, we have a traditional 3D printed part, and the other side you have a part that's been dual sculpted. And so what this really means is that instead of parts that are a rough approximation, I can create incredibly precise parts. So this gearbox is tolerance to 5/1000ths of an inch. That means you can create the same tolerances you get out of a machine shop, but again, sitting on your desk. And so I guess what this means is enough talking. So I'm going to try to do a live demo. So anyone who's ever done a 3D printer before is going to know that this is not always the easiest. Great. It's going to start going in a second, but it's quiet enough that we can keep talking.
It's moving.
Yeah, this is a video you guys can watch. So this part was printed earlier. This is one of the parts that you guys saw in the gearbox. So it's been printed, and now it's actually returning, and you can see it as it shapes away those layers, right? We're not getting parts anymore that are layers and these little imperfections. It's actually a machine quality part. So I just want to let you guys know that if you guys are interested and want to learn more, we have a special page on our website, fusemachines.com/NewTech. There's a special offer there for you guys to get involved. Yeah, so that's it. That's how loud it is. So it's nice and loud, quiet enough that you can run it in a office setting. And so the cool thing is that if you guys want to learn more, feel free to reach out to me. We'll be at the after party. Thank you guys so much. Feel free to sit around and watch it make a bunch of mess.
Questions?
Right on time. Good job. You're like 10 seconds left.
Yes. So our intellectual property is actually kind of a cool story. So we are, this printer itself is developed off of stuff that I worked on as a student at Oregon State. We have proprietary, go Bees. We have a proprietary portion of our software. So the real protection in this machine is actually the software that makes what we're doing right here possible. Now, there are patent pending stuff for future revisions of this machine. This machine, as it stands right now, is protected under a certain amount of trade secrets, but not actual patents. Yes?
How much?
Okay, so right now the printer is MSRPing for $3,000. If you go to the NewTek's link, it's actually $500 off for all of you. Yes?
So, obviously you don't want to put more material down in order to be able to shape some more.
Yes.
You have software that detects them all?
Yep. Yeah, so that's actually part of the proprietary tech, is the intelligent software that knows how to basically print more material than you would typically need to create the part to come back in and refine that. And that's a mix of proprietary stuff and then also leveraging some of the really awesome open source content that is part of the 3D printing community. So it's all one big package. Yes?
Since I can't find you on Google Maps, where are you located?
We have our facility out in the southeast, and so we're able to build around 5 to 10 printers a week out of there. And so we're hoping to expand into a bigger space, but for now that's where we are.
How much extra material has to get off?
So right now we're printing around 0.7 millimeters extra, which is not that much when you consider our printer does print with a 0.6 millimeter nozzle. So just like the other Nathan was talking about, large nozzles allow you to print faster, and when we both have the capacity to come in and refine that part, you're able to print fast and then come back and machine it away to create accuracy. So it's a lot like, I like to say, it's a lot like scribbling really fast with a pencil and then coming back to erase it to make it a really nice fine shape.
Your software, you mentioned the proprietary software a few times. Is it machine side or is it a plug into the CAD software, or are you using a custom CAD system?
We are using a custom host program, which is a custom program to run the printer. We also are developing our own slicer. For those of you who don't know, it's just the program that takes a 3D model and breaks it up into those slices of bread, like Alice was talking about. And then, so that's basically our tech, is the software behind the there actually is custom firmware. So there's custom firmware, a custom piece of software to run it, and then a custom piece of software to process the file before you can run it. So there's a lot of magic that happens behind the scenes, and I'm the lucky one because I'm the mechanical engineer, so I just have to press go. So, awesome. Thank you.